All right, welcome back. This is our final lesson on division of polynomials, and reminding you that we are on page 345 of the textbook. Now, also reminding you that division, remember division is one branch of simplify. Remember that simplify means to what? Simplify means to add, subtract, multiply, and divide. And we are focusing on division of polynomials, reminding you that when I write, for instance, quantity y to the third minus 8 multiplied by quantity y minus 2 to the negative 1 power. Remember that negative exponents mean move from what? Move from numerator to denominator. Move from the numerator to the denominator, so we're ending up with y to the third minus 8 over what? Y minus 2. So if we look at this as take this and move it to the denominator, we're looking at y to the third divided by y minus 2, and we have what? A binomial divided by binomial. And since we have binomial divided by binomial, since we have a variable in the denominator, technically this is called what? Rational expressions. So really, division of polynomials is the study of rational expressions. Okay, different types of rational expressions. Since we have a variable in the denominator, this whole thing is called what? A rational expression. That's the proper term. And we're looking at y to the third minus 8 divided by y minus 2 is to take this and use what? Long division. We've learned that we can use long division or we can use synthetic division. So long division says y to the third minus 8 divided by y minus 2. We start this process by asking what multiplies by the front to give the front, or what multiplies by y to give y to the third. Hopefully you say y squared. We take the y squared, multiply by both. Y squared times y is y to the third, and y squared times negative 2 is negative 2y squared. And remember, we put parentheses and subtract. So we're subtracting both. We don't like to subtract, we like to add, so change the signs and add. What happens in front? Y cubed plus negative y cubed cancels, leaving us 0. Negative 8 plus 2y squared. Remember, when we add, things have to match. Does negative 8 match 2y squared? No. So we put the largest degree term first. We put our y squared term, because it is second degree, first, 2y squared first. And we put our constant 8 last, because 8 has a degree of 0. Remember, 8 is y to the 0. Or 0 degree. We ignore the y to the 0 because y to the 0 is assumed to be 1. Now we start the process over again. What times y gives 2y squared? Hopefully you say 2y. Okay, so we take the 2y multiplied by y, we get 2y squared. Does the front match? Yes, it is supposed to match because you chose a number that would multiply by the front to get the front. Now take the 2y and multiply by the negative 2. 2y times negative 2 is negative 4y. Put subtraction of both, parentheses, change your signs, and add. 2y squared plus negative 2y squared cancels. Negative 8 plus 4y, do these match? No. This is a first degree term, or y to the first power, and this is a 0 degree term. They do not match, so we put the first degree term first, 4y, then put the minus 8, and start the process over again. What times the front gives the front, or what times y gives 4y? Hopefully you say 4, so take the 4, multiply by both. 4 times y is 4y, and 4 times negative 2 is what? Negative 8. We put subtraction of both, change your signs, and add. 4y plus negative 4y cancel. Negative 8 plus 8 gives what? 0. So we get a remainder of 0. And our final answer is y squared plus 2y plus 4. Now, can we use synthetic division? Yes. But if we're going to use this trick, synthetic division, we have to be careful to include every degree. So starting with our dividend, what is the largest degree? What is the largest degree of the dividend? Hopefully you say this is y to the third. So we're going to go y to the third all the way down to 0. So y to the third, y squared, y, and y to the 0. And now let's put in our constants. What is in front of y to the third? Hopefully you say a 1. So we're going to put a 1. And do we have a y squared term? No. The y squared term is missing, so we're going to put a 0. Remember, you have to insert zeros for any degree term that's missing. Now, is the y to the first term in the problem? No, so we're going to put a 0. And do we have our constant term, or our y to the 0 term? Yes, that is negative 8. Let's put this here. Now we need our little box. I'm a little off on space here. Hold on. Y to the third. Let's call that a 1. Let's call y squared 0. and then in our little box. In our little box goes the opposite of the number in the divisor. Since we have y minus 2, the opposite of negative 2 is what? Positive 2. And now, we're going to start this process of fake division or synthetic division by bringing down the 1, put it here. And do we multiply or add first? Hopefully say we multiply, then add, multiply, then add, multiply, then add, and we're done. So we're going to multiply. 2 times 1 gives what? 2. Now add. 0 plus 2 is 2. Now multiply. 2 times 2 gives 4. Now add. 0 plus 4 is 4. Now multiply. 2 times 4 is what? 8. Now add. Negative 8 plus 8 is what? 0. So notice this was y to the third. On the bottom we go 1 degree less. What's 1 degree less than y to the third? That's y squared. And all the way down to 0. Actually below 0. Y squared, y to the 0. And now the last one is your remainder. Now this is not how we write the final answer. We glue it back together. So we have 1y squared, which is written as y squared. We have 2y plus 2y. And what? Positive 4 is our constant. So plus 4. Then notice that this answer matches what? Matches this answer. And reminding you, when you guys get to pre-cal, what is going to save you all of that time? Synthetic division is going to save you a whole lot of time because it's so much faster than using long division. Okay? But does synthetic division always work? No. Synthetic division is a trick, and it only works. It only works when the binomial is first degree. I'm sorry, when the divisor has a degree of 1, first degree. Okay, I'm not going to get into that right now. But this is the process for using long division and synthetic division. When do we use? The question today is, when do we use long division? When do we use synthetic division? So what do we have here? We have y cubed minus 8 divided by what? Y minus 2. Question, what is in our denominator? I'm putting a box around it. What is in the bottom? Okay, what is in the bottom? In the bottom we have what? A binomial. Okay, so what is in the bottom? In the bottom is a binomial. When there is a binomial in the denominator, we use a process called either long division or synthetic division. But my question today is, what do we do with this problem? So we're looking on page 345. Let's see, 345 number 13. 345 number 13. What is different about this problem and the number written, or what is different about this and number 13 on page 345? Page 345, number 13 says 5x squared y, 5x squared y minus 10xy plus 15xy squared all over 5xy. What is different? What is different about this problem and this problem? Notice, what is in the denominator on the bottom? Okay, what is in the denominator down here? We have a binomial. What is this called in the denominator? Do we have any addition? No, this is called a monomial. Okay, so we're going to talk for a moment about how to deal with a monomial. This is a lot easier. Not nearly as much work. Much easier problem when there is a monomial in the denominator. So you ever get excited about this? This lesson is extremely easy when there's a monomial. Watch this. So the question is, first, let me write this problem over here. We have to talk a little bit about addition. So if I write 5x squared y minus 10xy plus 15xy squared over 5xy, my question is, does the x cancel with the x? No. Does the y cancel with the y? Absolutely not. Does the 5 cancel with the 10? No. Okay, so do these cancel? Absolutely not. Why do they not cancel? Let me show you. Okay, so this is a 10xy. Here, let me write that again. 10xy, and this is a 5xy. Does the x cancel with the x? No. Does the y cancel with the y? No. Does the 5 cancel with the 10? No. Why not? Because up top we have what? Addition or subtraction. Addition. What does addition do? Addition locks up every product to the left and to the right. Puts it in jail. Traps it. You cannot cancel this x with this x, nor can you cancel this x with this x. Okay, the addition locks up every term to the left and right. Do we have addition here? Yes, the addition locks up every product to the left and to the right. So the 15 is locked up, the x is locked up, The y squared is locked up. Everything on top is locked up because of the addition. The addition locks it up, makes it not free to cancel. However, question, is the 5 on the bottom free to cancel? Yes. Is the x free to cancel? Yes. Is the y free to cancel? Yes. Why? Because there's multiplication on the bottom. There's no addition in the denominator. The 5 is begging for something to cancel with it. The x is begging for something to cancel with it, and so is the y. But there's nothing for them to cancel with because the addition is locking up everything in the numerator. So what do we do here? Well, let's look at an example really quick. If I write 6 plus 3, or let's do this. How about, let's do 9 plus 6 over 3. Question, does the 3 cancel with the 6? Does the 3 cancel with the 6? No, the 3 does not cancel with the 6, leaving 2. Here, let me show you. First, tell me the correct answer to this problem. Tell me what the correct answer is before we do anything. Just look at it and see, what is the number? What is the answer here? Hopefully you say the answer is 5. Why is the answer 5? Well, because 9 plus 6 is 15, and 15 divided by 3 is 5. Do we all agree that the correct answer is 5? Yes, the correct answer is 5. Notice, we cannot cancel the 3 with the 6. If we try to cancel the 3 with the 6, we end up with a 2, and we get 9 plus 2, which is 11, which is the wrong answer. No, you can't cancel the 3 with the 6. That changes. We all understand that the correct answer is 5. We can't get 11. The 3 does not cancel with the 6. If you need to, rewind that and relook at that. We get 11. If we try to cancel the 3 with the 6, we get a 2. 9 plus 2 gives 11, which is the wrong answer. No. The 3 cannot cancel with the 6. Why? Because the addition does what? The addition locks up everything in the numerator. The 9 is not free to cancel. It's locked up. Is the 6 free to cancel? No, it's locked up. It's in jail because of the addition. However, is the 3 on the bottom free to cancel? Yes. There's no addition in the denominator. The 3 has multiplication either side of it. It's begging for something to cancel with it. So what do we do here? There is a way to cancel, but I'm going to show you how this works. There is a way to cancel. Watch. We call this process splitting the addition in the numerator. Watch. We can write this as 9 divided by 3, split the addition, plus 6 divided by 3. The 3 does not cancel with the 6. The 3 does not cancel with the 9 independently, but the 3 cancels with both. Notice, have we gotten the 9 and 3 separated from the addition? Yes. Is the 6 and 3 separated from the addition? Yes. So 9 divided by 3 gives what? 9 divided by 3 gives 3. 6 divided by 3 gives 2. What is 3 plus 2? 3 plus 2 is 5. Is this still the correct answer? Yes, we call this process splitting the addition in the numerator. Think of it like this. You have to split or free. You have to free the 9 and the 6 from the addition so that they can cancel with the independent 3 on the bottom. And notice, 3 does not just cancel with 6. 3 cancels with both. Okay, so we call this process splitting addition. When do we do this? What do we have in the denominator? A monomial. What do we have in the denominator? A monomial. When does this process of splitting the addition work? It works when there's what? A monomial in the denominator, or something in the denominator that has no addition. Everything is multiplication in the denominator. Now, let's look at this process up here. So we can split the addition to simplify this. Watch, this is so easy. So we're going to say that this is 5x squared y over 5xy minus, we're splitting the addition, 10xy over what? 5xy plus, split the addition, 15xy squared over what? 5xy. Now can we cancel? Yes. Notice that the 5xy does not cancel independently with the 10xy, but it cancels with all 3 after splitting the addition. Now do the 5's cancel? Yes. 5 cancels with 5, leaving 1 and 1. X cancels with x squared, leaving an x. Y cancels with y, leaving a 1 and a 1, and our final answer is x. Now, 5 cancels with 10, leaving what? A 2. X cancels with x, leaving 1s and 1s. Y with y, leaving 1 and 1. What are we left with? A minus 2. Now, 5 cancels with 15, leaving what? A 3. X cancels with x, leaving 1 and 1. Y cancels with y squared, leaving a y. So we have what? Plus 3y, and we are done. That's it. You have fully simplified this question. How easy is this? Much easier. This is much easier than long division or synthetic division. So we get excited. We get excited when we see a monomial in the denominator because the process is a lot easier. So if you have a monomial in the denominator or all multiplication, we split the addition. When there's a binomial, a lot more work. When there's a binomial, you have to use what? Long division or synthetic division. Long division or synthetic division. Now let's look at another example, number 15. Okay, so number 15 says 4a cubed b. I'm going to keep this very simple. 4a cubed b minus 6ab. I'm just going to write it a little different. Plus 2ab to the third. No, 2ab squared. Let's write it. I'm going to write it a little different than the book says so that you understand how to read this two different ways. Multiplied by quantity 2ab to the negative 1 power. Notice. Question. Where does the 2ab to the negative 1 power move? This moves where? This moves to the denominator. Notice, is this, underlining, what's moving? Is this a monomial or a binomial? Hopefully you say that this is all multiplication. This is a monomial. I'm going to write mono. This is a monomial. This moves to the denominator. We have what? 4a to the third b minus 6ab plus 2ab squared all over what? All over 2ab. What is in the denominator? Hopefully you say this is a monomial. It's all multiplication. So we use a different process here. We don't have to use long and synthetic division. We can just write this as what? We can write this as 4a cubed b minus, 4a cubed b over what? 2ab minus 6ab over what? 2ab plus 2ab squared over what? 2ab. Notice the 2ab is written common to all, and now we cancel. Does the 2 cancel with the 4? Yes, it leaves a 2. A cancels with a cubed, leaving what? A squared. B cancels with b, leaving 1s and 1s, so we write 2a squared as our final answer. Now, 2 cancels with 6, leaving a 3. A with a, leaving 1 and 1. B with b, leaving 1 and 1. We have what? Minus 3. Now, 2 with 2, leaving 1 and 1. A with a, leaving 1 and 1. B with b squared, leaving what? A b. And we have plus b, and we are done. So that's all there is to this process. Now, really quick question. Can you identify your process from here? Can you see a monomial written here? Hopefully you say yes. So let me write these two problems. You should be able to identify, this is how it's written on the test. Running out of space. Let me see here. 5x squared y minus 10xy plus 15xy squared multiplied by 5xy to the negative 1. Y cubed minus 8 multiplied by y minus 2 to the negative 1. If you were looking at both of these problems on the test, now on the test I will say use long division or use synthetic division. I will tell you specifically what to use when dealing with this problem, but you should be able to look at these two and tell the difference. Question, what are we dividing by on the first question, on the top one? What are we dividing by? What's moving to the denominator? What is moving to the denominator? Is this a monomial or a binomial? Hopefully you say this is a monomial. If this is a monomial, what do we use? We don't use long division, synthetic division. We split the addition in the numerator like we did here and cancel. So split the addition and cancel. However, what's moving to the denominator here? Hopefully you say this is what? Not a monomial. This is what? A binomial. A binomial is moving to the denominator, so we don't use the process of splitting addition. We use process of what? Long division or synthetic division. Now, let me show you what's going on here. So if I write here, quick question. Let me show you this example. If I write quantity x squared plus 3x minus 40 multiplied by quantity x minus 5 to the negative 1, does this equal x squared plus 3x minus 40 over x minus 5? Is this true? Yes. What is in the denominator? What is in the denominator? Hopefully you say a binomial. What process are we supposed to use here? We're supposed to use long division or synthetic, but my question is why? Well, let me ask this question. Can we split the addition? Can we split the addition? Yes, we can split the addition. Look, is this x squared over x minus 5 plus 3x over x minus 5 minus 40 over x minus 5? Is this true or is this false? This is true. Yes, this is true. Yes, you can split the addition. You can always split the addition in the numerator. You can always split the addition in the numerator, but you cannot split the addition in the denominator. I'll talk about this in a moment. Can you always split the addition in the numerator? Yes. So we write this as x squared over x minus 5, 3x over x minus 5, 40 over x minus 5. Is this true? Yes, it's true. Yes. But does this get us anywhere? Is this simplified? No. Is this process going to work? No. Why? Because we have a binomial in the denominator. My question is, does the x cancel with the x squared? Does the x cancel with the x squared? No, it does not. It does not cancel. Why? It does not cancel because what do we have in the denominator? We have addition, and the addition locks up both terms. The addition does what? Locks up the x and the 5. The addition does what? Locks up the x and the 5. Is the x squared on top free to cancel? Yes, but is there anything to cancel with it? No, because everything is locked up. Is the x on top free to cancel? Yes, but is there anything on the bottom for it to cancel with? No, because everything's locked up. You say, well, let's split the addition. No, you cannot split addition in denominators. You're stuck. You get stuck on this problem if you try to do this. So when you have a binomial, notice, the reason we can't do this is because we're going to get locked up in our denominators because we have a binomial. So the process to simplify is to use long division or synthetic division when you have a binomial in the denominator. However, if we say this was here, if we say not x minus 5, but we say 5x, now this is what? This is no addition. This is multiplication. This is a monomial 5x. Now we can split the addition successfully. We say that this is x squared over 5x plus 3x over 5x minus 40 over 5x. Now do things cancel? Yes, because we have what in the denominator? Monomial. Does the x cancel with x squared? Yes, it leaves an x. Does the 5 cancel with the 3? No. Does the x cancel with the x? Yes. Does the 5 cancel with the 40? Yes, it leaves an 8. Be careful here. You still have things in your denominator. You have x over what? X over 5 plus what? 3 over 5 minus what? 8 over x. So even, yes, this is final answer. This is the final answer. So even in your final answer, can you still have things that are left in your denominator? Yes. Okay, but you just simply cancel. Can you cancel? Yes, because you had a monomial in the denominator. So one more quick example. This is the hardest that it gets right here. So let's look at this one. Number 17. Number 17 on page 345. I'm going to spice it up just a little bit more like your test question. So let's look. This is like your test question. 9n cubed p to the third minus 18 n squared p squared plus 21 n to the negative 2 power p to the third multiplied by 3 n to the negative 2 p to the negative 1. Well, it's just p to the negative 1 power. Let's do this. Okay, so now first we look at what is moving to the denominator. Is this a monomial or a binomial? Hopefully you say it's all multiplication. This is a monomial. We're looking at 9n cubed p cubed minus 18n squared p squared plus 21n to the negative 2 p to the third all over what? All over 3n to the negative 2 p. I guess technically this is not called a monomial. Reminding you 3n to the negative 2p is actually the same as 3p over n squared. There's technically a variable in the denominator, so this is technically called a rational expression, but we treat it the same. Now, the question is there any addition? Is there any addition? No, this is all multiplication, so we split. We're going to split the addition. We have 9n cubed p to the third over what? 3n to the negative 2p minus 18 n squared p squared over 3n to the negative 2p plus 21 n to the negative 2 p to the third over 3n to the negative 2 p. I want you to notice that when we move this monomial to the denominator, what changed? The outer exponent changed from negative 1 to positive 1, but did the inner exponents change? No, the inner exponent is still negative. Now, what does n to the negative 2 mean? N to the negative 2 means what? We're going to move it to the top, and it's going to become n to the positive 2 power on top and cross it out. So n to the negative 2 will move to the top, become n to the positive 2. Now, cancel your 3 with your 9, you're left with what? You're left with a 3. Now, n cubed and n squared, we have 3 n's multiplied by 2 more n's, leaving what? N to the 5th. N to the 5th. And now p cancels with p to the 3rd, leaving what? P squared. So we have a p squared. And we're done with the first term. 3 cancels with 18, leaving what? Minus 6. N to the negative 2 moves where? Moves to the top, becomes n squared. Okay, so it's negative 2 power means move it to the top, change the sign of the exponent from negative to positive. N squared times n squared, 2 n's multiplied by 2 more n's. We're adding the exponents, n to the 4th. And p cancels with p squared, leaving what? A p. Now, 3 cancels with 21, leaving what? A 7. N to the negative 2 moves to the top, becomes n squared. N to the negative 2 on top moves to the bottom, becomes n squared on the bottom. And our n squared cancels with our n squared, leaving 1's and 1's. P cancels with p cubed, leaving a p squared. And our final answer is plus 7p squared. And you guys are done with this lesson. Good luck on your homework.